Hi everyone. In this video, which is probably one of two different videos, we are going to talk about what the SAT calls additional topics in mathematics, which basically mean we are going to go over geometry and trigonometry concepts that you may have forgotten over time. While this section of the four domains that we're going over in this cram session uses the least amount of questions, usually less than 10% of the questions come from this category. However, these are the ones students miss the most, usually because a lot of these topics we're going to go over in these videos are things you probably haven't seen since you took geometry, or maybe rusty even in some trigonometry stuff. Maybe some of you haven't taken trig, and the only trig you know is what you learned in geometry. So this video is going to help to kind of freshen up and go over some of those things. Now, just to make sure you know where to access everything, go to the content library where it says additional topics. You will see these four things, which we will be going through over the course of these videos. So this is the math intro. I'm not going to read this, but please take a moment to read over. And these are the specifics from SAT College Board that they want you to look over. What I've done actually, though, is I've put it together into this warm-up here, which if we were in class, we would go over. What I really want you to do with this is to pause this video for a moment, and I'll scroll through. Look through these topics that you learned in geometry and make any marks or notes of things that you may have forgotten or things you may have not known. These are things that when we have meet either in person or in the case of this school year, we're going to be meeting virtually. You can ask questions and stuff about these topics, and I can go over them. So these are the topics from geometry. And then the bottom here are some random topics from coordinate geometry, trigonometry, and so on. And the last thing I want to mention before we get into practice problems is you are given a formula sheet for the SAT. So I've taken a screenshot of that and listed it at the bottom here of the page. Please make sure, while you don't have to memorize these, familiarize yourself with it so that you know when you're going through questions that you can reference back to these. I will reference these as we go through some of the questions here. So the purpose of this main video, and as well as probably the second video I'm going to need, is I'm going to use this ATM practice problems worksheet, which is a total of, it looks like 12 problems we're going to be going through. I'm going to go through them quite swiftly, so be sure to pause, rewind at any point if there's something that I say that you may have missed along the way, but I'm going to do my best to kind of quickly and efficiently go through these different problems. So we're going to start with number one. And another side note, as before I get into the problems, if you want to try these first, please feel free to pause the video now, go through and try them, and you can come back through my tutorial as I go through these different problems. So this question is mainly looking at using similarity here of triangles. So similarity basically means that these two triangles that we're looking at, ABE and EBC, are going to be proportional to each other. The way we know that is that line L is parallel to line M. What that means is that this angle A and this angle C have to be equal to each other. Likewise, this angle B, which was 90, is also going to be equal here. And the last little note here is that these two angles here and here are equal, and that's because they are considered vertical angles. So now that we have that information, we need to find the length of AC. Now, in order to do this, this is going to be a two-part problem. So we need to figure out the length of the entire AC. I want to start with AE first. Now, because this is a right triangle, this has a length of 5, this has a length of 12, we can use the Pythagorean theorem to get the first section of this. So this would be 12 squared plus 5 squared equals x squared, which is 144 plus 25. As you may know, that actually comes out to be a perfect square, 169. So x is equal to 13, but you need to be careful because the answer to this question is not 13. In fact, we still need to go down and figure out this length EC here. And this is where similar triangles are going to play a role. Since these two shapes are similar to each other, we're going to set up a proportion to help us find this. I'm going to call this side x. So I'm going to write the proportion x, and the side that it corresponds to is the side that is also the hypotenuse on the other shape, which is 13. That is going to be equal to, now the question is, do we pick well, we have to pick the 1 because since the x is the hypotenuse here, we have to pick the 1 since we do not know the length of BC. I'm going to put a 1 there. The 1 is going to correspond, that is considered my short leg, so I'm going to compare that with the 5. So I'm going to set up my proportion. We're comparing the small triangle to the large triangle. We're going to cross multiply. And when we solve this, we're going to get 2.6. So what we need to do as our final answer is add these two together, and that's going to give me a total of 15.6. This is a grid in question, so you would have to grid in those 4 spaces. Moving into the second question, this is talking about a regular polygon. Quick reminder, regular means all sides and all angles are going to be equal. It also has 9 sides. That's another important fact here. And it's been divided into 9 congruent isosceles triangles. Now, quick reminder, the word isosceles means 2 equal sides, and congruent means the triangles are all the same. And what I mean by same exact length, same exact angles, and so on. So we need now to find what the value of x is going to be here. Now, a couple things to take away from this. We know that a triangle has to add up to 180 degrees. Since we know this angle right here is x, another thing to point out is that this angle over here is also x. Why do I know that? Well, that's because of the word isosceles. So we can say that these two sides are equal. Now, how you go about solving this, you can go 2 different ways. One way that I know a lot of students like is that they know all of these top angles up here have to add up to 360 degrees. Well, 360 divided by 9 triangles means that those angles each are 40 degrees. Since we know that's 40 degrees, that means the other 2 angles have to add up to a total of 140 degrees. Since we know they both have to add up to 140, divide that evenly by 2, and we get an answer of 70. Alternatively, which is the harder route, is that you could actually go and find each of these angles in this nonagon, 9-sided polygon, which you could use the formula n minus 2 times 180 to figure out your sum, and then divide everything by 9, but then you have to divide it in half. So not the easier of the 2 ways, but definitely you can still get to the same result going a different path. Moving on to question 3. This question strictly is looking at the word inscribed and having us look at the vocabulary behind it. So AXB, which I'm going to label in light blue here, and AYB, which I'm going to do in the green, it looks like, okay, are inscribed in the circle. Which of the following statements is true? So what they're saying is that the measure is either greater, less, or equal, or not enough information. So we're trying to establish just a relationship between them. Now, you can always use your intuition here. Looking at this, do they look to be less, equal, greater? That's the first thing I would go through my mind. The second thing we're going to talk about is what the word inscribed angle actually means. Inscribed angles are angles at which their vertex is on the circle, okay? So that's the reason why we're considering them inscribed angles. One thing you may remember from geometry is that inscribed angles are always going to be 1/2 of the arc. So if that yellow arc right there is 30 degrees, this angle right here has to be 15 degrees. Now, interesting fact, and this is what's going to lead to the answer here, is that if I drew another inscribed angle from the same 2 edges of that arc, this angle would also be 15. So if we make that conclusion, what we might notice here is that, let me get the right highlighter out here, that arc AB, okay, is whatever number it is. We know that AYB has to be exactly half of AB, and we know that angle X has to be exactly half of that as well. So that means angle Y and angle X have to be the same. That would lead me to conclude that C is the correct answer here. We're going to move on to number 4, which I'm going to tell you ahead of time. This is probably the hardest question on this practice set. So this is the one that's going to take the most time. But what I can tell you right now is if this question would be your question 38 or your question 20 on an SAT, meaning this will be one of the last questions you would come across. Really tough question, utilizes a ton of different geometry concepts all put together here. So let's go through it and let's talk through it. So in the figure above, O is the center of the circle, and segment BC, and here's our first keyword, is tangent to the circle at B, and A lies on segment OC. Lastly, another important thing here is OB/AC are both equal to 6. We want to find the area of the shaded region. So let's go ahead and label this as 6. We'll label this as 6. And there's one other side that has to be 6 here that they didn't tell you directly, and that is OA. The reason why? A radius to a circle, okay, goes from the center and radiates out to each of the edges of the circle. Those lengths will always be the same no matter where you draw it. So we now have ourselves a triangle, which we know 2 sides of. Now, finding that third side, we'll talk about that using this word tangent, okay? The word tangent means a circle, or I'm sorry, a line which intersects a circle or a curve exactly one time. Another random theorem from geometry that you need to know is that when a line is tangent to a circle, it will always be perpendicular to the radius that also intersects that circle. So that tells me that this right here is a right angle. This means that this triangle is a right triangle. And I'm going to draw it standing up straight here so that you can take a look at it. So we're going to call this B, O, and C. And we know that this length is 12 and this length is 6. This angle right here is 90 degrees. Now, a lot of you may say, well, let's use the Pythagorean theorem here. And in fact, this would be a good place to use such a thing because we would need to find the area of the triangle. Area is going to be 1/2 the base times the height. But there's something here that's going to take us to that next step. So if you go through this Pythagorean theorem process, you are going to end up getting the angle, the length, but it's going to be a decimal value, which will help you find the area of the triangle. But one thing I want to do is I want to take a look at our answer choices real quick. You see how the answer choices have some sort of a radical answer? Mine is an answer with a pi. Well, if we're trying to figure out what this is going to be, the area of the shaded region that I'm going to draw here, or trace out, I guess, okay? This whole region right here, okay? That shaded region can be found by finding the entire area of the triangle minus the area of the sector that we're not counting. So this is going to be the area of the sector. So the sector, and then we'll call this triangle. So it seems to me that they're giving me all the answers for the triangle portion right here in radical form. So either using Pythagorean theorem, which, hey, that would give you down to a 50-50 shot. I would do this Pythagorean theorem, 6 squared plus x squared equals 12 squared. So let's write this out. And again, keeping in mind that I want my answer to be in radical form. That's going to be important here for doing this. So the answer, x squared is 108. X equals root 108. If we break that down and we set the radical, I should say, I'm sorry, we would get like 54 and 2. Divide that by 2 again, maybe. We get 2 and 27. 9 and 3. 3 and 3. So we have our pair of 2s, a pair of 3s. It appears that this height is going to be 6 root 3. So finding the area of the triangle now should be pretty easy. We're going to do it over on the right side because I'm out of space here. So it's 1/2 6 times 6 root 3. So that's going to be 6 times 6 is 36 times 1/2 is 18. The area is 18 root 3. Here's the good news. We can eliminate 2 choices from this. So we're down to A versus B. But what we need to do now is find the area of the sector. And this is where now we have to use a little extended knowledge. In order to figure out the area of the sector, I need to figure out what that angle is right there. Well, if you look at the ratios here, here's going to be our big connection point here. 6, 12, and 6 root 3. Very similar to right triangle, and as you may know, you need to know your 30, 60, 90, and your 45, 45, 90 triangles for the SAT. They do give you those ratios on page 1, but you still need to know when to use them. Take a look. This is actually going to be a 30, 60, 90 triangle. That's the reason why they gave the answers as radical to help you see this. So this is 60 degrees. The area of a sector is always going to be pi r squared, the whole area, times m over 360, meaning what part of the circle do you want to find the area of? We know the radius here has to be 6. And m over 360, well, since the angle is 60, we're going to say 63 60ths. What that actually means, let's write this out, 36 pi, is that we're finding 1/6 of the entire circle. 1/6 of 36 means that the area of this sector has to be 6 pi, and that's going to lead us to giving the answer here as B. Now that last part here, as I wrap up part 1, if that confused you a bit, keep in mind that if you can just get the triangle part, the Pythagorean theorem part, you already have a 50-50 shot at getting this question right, which is good news. So getting that extra step is just giving you the guarantee of getting the correct answer. So that concludes part 1. Funny enough, we'll probably get through all of the other questions in our part 2 video, but that'll conclude this part. Thanks for watching.